Hey everybody, this is going to be our last video for 8.4 on trig substitution. So we went over a couple of examples in the first two videos, and we're substituting trig functions as our variable in our integrand. So let's work on this example 3. We're going to integrate dx, or 1 over square root 25x squared minus 4, and then just a note that x is greater than 2/5 in this case, just to make sure that this quantity is real. Alright, so before we get started on this one, this doesn't quite look like any of our formats here for when we know we're going to plug in our trig functions, but we can make it look more familiar. So what I'm going to say here, before we go into our regular 4 steps, we're going to factor out this part that's making this look a little weird. So think about what you have here. In the format you substitute in for, you have something squared minus something squared in options 2 and 3 here. And in option 3 you have x squared minus a squared. But right now we have a 25x squared. So I'm going to factor out this 25, and then maybe this will make this look better and we can figure out what's going to be substituted exactly. So in this square root, if we take out a 25, well then what's left is an x squared. But if you think about it, if you factor out a 25 from 4, so minus 4 here, if you factor out a 25, there's no 25 here, so you basically are dividing by 25 if you factor that out. And if you want to check yourself on this one, if you're not sure, distribute that 25 back in and you'll get negative 4 like you started with. So then this becomes, if you think about this, you can separate this square root because you're multiplying. So this becomes square root 25, which is just 5. And then what's left inside is this other quantity, x squared minus 4 over 25. Let me make this a little bigger. 4 over 25. Okay, so that's going to be our preliminary step before we even get into step 1. Step 1 being recognize which format we're working with. And I already mentioned it is going to be this last one. We're substituting secant in for x, a times secant theta. Just like the last two examples, I'm going to break down how you know to choose this in case you don't have these listed for you, how you know to choose secant theta in this case. So if you think about it, with our integrand, we have x squared minus something else squared. So whatever's first and it's subtracting another value, that's the biggest value, so that's our hypotenuse. And so what we're subtracting is the other leg of this triangle squared. So if you think about that, what squared makes 4 over 25? Well, that means that this side A is 2/5, because 2 squared is 4, 5 squared is 25. And then the last side of this triangle would be the hypotenuse squared minus this leg squared, square rooted. And that's exactly our integrand right here, this value, this quantity. And so in that case, if this is our angle theta, we know that the relationship should be x over a. So in this case, that's hypotenuse over adjacent, so that's secant. So secant theta is x over 2/5. And so that becomes, if you times 2/5 out on both sides, that becomes 2/5 secant theta is what we're going to substitute in for x. All right. And so what we have here is now step 2. I'll go ahead and just move it down here. Step 2 is going to be to find dx. And so dx is just this derivative of secant 2/5 secant theta. So 2/5 secant theta tangent theta d theta is this derivative that we're going to plug in. So we're moving on to step 3, which step 3 is to substitute and simplify. So substituting into our integral, we're going to use this version of it because we simplified it. So we have integral of, I'll go ahead and just leave the dx on top, so this whole quantity is going to go on top. So 2/5 secant theta tangent theta d theta. And on bottom we have 5 outside the square root times the square root of x squared. X was 2/5 secant theta. So 2/5 secant theta squared minus 4/25. Okay, there's a lot of things going on here. Let's just keep this organized. Okay, this is the 2/5 on top. Square root on the bottom. All right, and we did our substitution. So let's start making this look better. I always start with the square root, so let's go ahead and go there. This is, if you square this out, square root of 4/25 times secant squared theta minus 4/25. And what we've done on the previous examples, and we're going to do now, is also factor out this value. So 4/25 gets factored out, and we have a secant squared theta minus 1. And whenever we do this factoring, it always leads us to another trig identity that we know. So this is tangent squared theta. Okay, continuing to simplify the square root. This is now square root 4/25 times tangent squared theta, and then we take the square root. Square root of 4/25 is 2/5. Square root of tangent squared is tangent, so tangent theta. So this became our denominator here times 5. Okay, so this, I'm going to run out of room, so I'm going to take this, I'm going to write it right under here. So this denominator is 2/5 tangent theta times 5. So I'll clean this up and then we'll continue. All right, continuing from where we were at, I just moved this right underneath our original integral. Let's keep simplifying. So we have now, let's say we have the 5 are going to divide out here. Okay, so this is just going to be 2 tangent on bottom. And then we have a fraction over fraction. So this is getting kind of ugly to keep these fractions over fractions. So let me deal with those first. First, let's take out those 5s. And then we have a 2 over 5 over 2. So the 2's actually divide out. If you think of it as flipping and multiplying, just show you really quick. This is 2 over 5 over 2, which is the same as 2/5 times the reciprocal 1/2. So that's just going to be 1/5. So 1/5, and then we have tangent theta on top and bottom, so those divide out as well. So secant theta d theta. And so this is so nice. We've seen this come up over and over again in some examples. We know what this is at this point. This is 1/5 ln secant theta plus tangent theta. And then remember last step, step 4, resubstitute because you never had thetas in your original integral. So we have to go back to what we had in terms of x. We know what secant is in terms of x. So let me write this better. Originally we knew secant theta was x over 2/5. So that's x times 5 over 2. So flip and multiply the 2/5. So secant theta is 5x over 2. Okay, so we have 1/5 ln secant theta again is 5x over 2. And then tangent theta, we do need to go back to our triangle really quick. So tangent theta is opposite side over adjacent side over 2/5. Okay, let's flip and multiply, make that look a little better. So plus 5 times the square root over 2. So x squared minus 4/25. And then plus c. You could make this look a little better so you don't have a fraction inside this bigger fraction, but we'll go ahead and leave it like this. And so that is our final answer, and that concludes this section.